So in this first set of problems, you are trying to identify the form, what the details are, and then actually sketching the parabola that goes with the equation. You could always go to the internet and type in Desmos graphing calculator as a way of checking your graphs. Accuracy is extremely important, so knowing the points we have can be real helpful in terms of identifying the location of parabola. So the more information we can determine based on the equation, the more accurate the graph will be in the end. So the first problem is in factor form. The a value is 1, so that means that the shape of the parabola will look like a parent function. So when you go from the vertex, you go over 1, up 1, and whether you go to the right or to the left, that's the general form for a parent function. The intercepts are at 3, 0, because if I stick in 3 in the first parenthesis, 3 minus 3 is 0, and then the other one is negative 5, 0. If I stick in negative 5 for x in the second parenthesis, I get 0. So 3, 0, negative 5, 0. Now one of the things we talked about is trying to identify where the vertex would be located at. And the graph for a parabola is symmetrical, which means the vertex of the parabola should be halfway between the negative 5 and the positive 3. Negative 5 and positive 3 are 8 apart, so that means I'm looking for the number that's exactly halfway between that, which would be 4. That would be negative 1. So that means the vertex should be somewhere along negative 1. To figure out exactly where that location is, as we did in class 2 days ago, we would replace x with negative 1 and figure out what the answer is for y. So y is equal to negative 4 times positive 4. So y is at negative 16. So this graph here would actually fall off the grid paper based on the grid paper that's given. So the graph itself would come down like this. It would definitely go below the graph paper. And the vertex itself, I probably would mark that as negative 1 comma negative 16, especially since it falls off of the grid paper. In the second problem, we are actually given the equation in vertex form. So the vertex will be 3, 4. Again, if I stick in 3 in for x, that creates that 0. So we're always trying to make zeros with the x expression. So if I go over 3, down 4, this is a negative 4. The a value is negative 1, which means it's being flipped. And it's negative 1, so that means that the graph itself is going to have the shape of the parent function, but it's going to be flipped over. So I'm going to go over 1 to the right and down 1 instead of up, 1 to the left and down 1. So the parabola will look something like this. And the third problem, based on our conversation from 2 days ago, the standard form tells us the y-intercept, so it's going to be at 0, negative 1. Also, we can determine the vertex for this parabola by using the opposite b over 2a. So the b value is 2, which is why in the problem I've used negative 2. And then the a value is 4. So it's going to be negative 2 over 2 times 4, which is negative 2/8, or negative 1/4. To get to the y value, we would stick in the x value to figure out the answer. So it would be 4 times negative 1/4 squared plus 2 times negative 1/4 minus 1. That's all the further I'm going to go. As I mentioned before, like if you got the answer to these problems, and you can always use the Desmos graphing calculator app on your computer. There's also, I think, a button on the welcome page to get to that calculator and check your answers. For the last one, we have a vertex of negative 2, 5, the a value is going to be 1. So to get the -2, we're looking for a value that makes x plus 2 equals 0. So we're going to go left 2 and then up 5. The a value is 1, which means it's going to look like the parent function. So we're going to go right 1, up 1, left 1, up 1, and that will give us the shape of that parabola. In these problems, we're wanting you to do the exact equation. We're given a vertex, so we're going to start off in vertex form. And then we're going to replace the h and the k with 4 and 1. Now to find the a value, we're given an x value and we're given a y value. So what we're going to do is we're going to replace the y with -5, and we're going to replace the x with 0. And then we're going to solve for a. So it'll be -5 is equal to a times -4 squared plus 1. So -5 is equal to 16a plus 1. Since -4 squared is 16. Subtract 1 from both sides. So -6 equals -16a. And then the last step is we're going to divide both sides by -16 to get a value of 1a. So we end up with the 6/16 or 3/8. You divide both the 2 and the 16 by 2. So the final equation is y is equal to 3/8 times x minus 4 quantity squared plus 1. In the last problem, we're given the intercepts, which means factor form. So y is equal to a times x minus r times x minus s. It's really important that you're working through these equations, you understand what the general form looks like, because the next step is really just a substitution problem. So y is equal to a times x minus 5, using 5, 0, and x minus -7, using the -7, 0. In the second parenthesis, because of the x minus -7, we're going to turn that into addition. We're given a point, so we're given an x value and a y value. So y is equal to a times 0 minus 5 times 0 plus 7. So 4 is equal to a times -5 times 7. So 4 is equal to -35a. Finish the problem off, we'll divide both sides by -35, so we get the value of just a single a. So a is equal to -4 over 35. So the final equation in factor form is y is equal to -4 over 35 times x minus 5 times x plus 7. So as we continue working through chapter 5, the warm-up problems will have a lot of practice with graphing, identifying the form and the characteristics. Also, you'll see a lot of problems involving trying to find the exact equation when given the solution.